Hello, everyone. My name is Belmiro. I work at CERN. So what this talk is about is I'm going to talk about my experience upgrading Nova in Newton with CellsV1 to Queens with CellsV2. So CERN is the European Organization for Nuclear Research. Its mission is to do fundamental research, especially in the field of particle physics. One of the main goals of CERN is basically look into hard questions, so how the matter is made of, what is dark matter. And is one of the biggest international scientific collaborations in the world. It has 22 member states, many more agreements to other countries, and 10,000 scientists for more than 100 countries work every day at CERN. So what this picture, what it is the LHC, the Large Hadron Collider. It's the largest particle accelerator in the world. It's a ring with 27 kilometers. And it is underground, 100 meters underground in a tunnel. So it's what you see there. Those pipes are superconducting magnets that to work, they need to be cooled down to minus 271 degrees Celsius. So very, very low temperature. It's even colder than the outside outer space. So what happens here is the LHC accelerates two beams of particles very close to the speed of light. And we made them collide in very precise points inside these huge detectors. And a detector is basically a digital camera. However, it takes 40 million pictures per second. This produces up to 1 petabyte of raw data per second. Of course, you cannot handle all that data. So the detectors have filtering systems to filter all the data and select only the interesting physics events. And we only store those. And this is around few gigabytes per second that we store at the CERN data center. So last year, CERN stored around 70 petabytes of data that needs to be analyzed. And to analyze all this data, we do it in our OpenStack Cloud. And this is one of the dashboards for you to have an idea of the size of the cloud. So you can see that we have 316K cores, more than 9,000 hypervisors, more than 4,000 projects, more than 3,000 users. This was taken last week. OK, so we are running CellsV1 since 2013. We deployed into production 5 years ago using cells. At that time, it was only cells, not CellsV1. And basically, what the cells do is to shard your message broker and your DBs to allow to scale your infrastructure without overloading these components. But there are many other advantages. So we have 2 data centers, and we don't have regions. We only have 1 region. And this allows us to scale transparency between these data centers. Users only know one endpoint, and they may be creating instances in one of those 2 data centers. One of the important aspects of CellsV1 is availability and resilience. So if one cell goes down, only the users that have instances in that cell are affected. All the others will not notice. So we are able to isolate failure domains. One of the use cases that we have is to dedicated cells to projects. So basically, entire cell, only a project will be able to create instances in that cell. Also, we can organize our infrastructure by hardware type. So each cell is a different hardware type. And it's a very convenient way to introduce new configurations. So we want to test a new configuration. Instead deploying everything to all cells, to the entire cloud, we do this per cell. Of course, it has some disadvantages as well. So this has been unmaintained for a long time now. And one of the big reasons is because the design decisions that were made when cells were developed. And the reason is because it's a completely different code path. So very difficult to maintain. And because of that, the new features that have been added to Nova are not included into cells. Like, for example, aggregates, server groups, security groups, if you are still using Nova Network. So this is a very high-level view about the CERN Cloud architecture using CellsV1. So you have the Nova API servers, the top cell controller with 1 dB and the RabbitMQ cluster, and then a lot of the cell controllers and connected to a lot of compute nodes. Each cell controller has its own database and RabbitMQ. And we have a lot of them. One particular aspect of this infrastructure is that the controllers are actual virtual machines that run in the infrastructure, so in the normal infrastructure. So now going more into detail to show which Nova components we run. So in the API nodes, of course, we run Nova API. We have 10 of them. Well, this was in CellsV1 Newton. We had 10 of them for the entire cloud. Top cell controllers, we run the Nova VNC proxy plus the Nova cells, 4 of them. And then for each cell controller, it's a bunch of Nova services, Nova cells again. Half of them are still running Nova Network, and we only have 1 per cell. So we don't have any high availability at cell level in the control plane. And then we have a lot of compute nodes, around 200 per cell, that are connected to this controller. So in total, in our cloud, we have 70 cells. OK. So Nova team has been working hard in the development of CellsV2 for a long time. The major difference with CellsV2 and CellsV1 is that with CellsV2, even if you have a very small cloud, very few compute nodes, or a large infrastructure, we'll be running the same code path. The other difference is that there is no DB synchronization anymore. So that thing that was most of the times out of sync was removed. So we're looking to this. We are in Newton. We want to move to CellsV2. So how are we going to do this? How are we going to plan this? There are a lot of changes that were introduced in Newton, like the introduction of placement. So what we decided was to migrate to Ocata first, figure out how to deploy placement, and then instead going to Pike, that is the first release that supports CellsV2 with multiple cells, go directly to Queens, just because there are a lot of new features there. And also we can backport some of the features from master. So this is the plan. So let's start with this. We decided that we're going to upgrade to Ocata. So we need to enable placement. Placement was introduced in Newton. It's required in Ocata. However, with CellsV1, the Nova scheduler runs per cell. And when placement was developed, well, Nova developers were not looking into this for CellsV1 deployers. This will be for the generic case. So how can we deploy placement with CellsV1 in a large computer environment? Placement is not cell-aware. And of course, since it will be a dependency for the scheduler, we are a little bit scary to deploy this in the cloud and put all the schedulers depending on this. So we decided instead of deploying a global placement, deploy a local placement per cell. So how we did it? So we used the trick of regions to deploy a placement per cell. So we created a new region per each cell that we had, so 70 new regions. We created a new placement endpoint per region. Of course, 70 databases were not enough, so we doubled that number, because now we needed to have the Nova API DB per cell as well for each of one of these placements. And we started running the placement service in the cell controller. And of course, then configured compute nodes to point to that placement. So as an end result, for each cell, we have the Nova API DB plus the placement API running. And during this process, everything went smoothly, basically, very smooth. Placement was basically taking care of 200 nodes of the cell, no major issues. The only thing that we found was, because this was not made to be configured in this way, the build requests were not deleted in the top Nova API DB. So there is a patch for that. That never passed the test, but we were running this patch anyway, and we didn't find any issue. And one other thing is, if you deploy this at scale, we need to care about keystone. You see, when we started to introduce placement in the different cells, that the load into keystone increased more than doubles. So it's something to take in mind if you're deploying this. OK, so in this, we are in the point that we are running Newton. We deployed one placement API per cell. So we are ready to upgrade to Ocata. And upgrade to Ocata, there is no major issue. It's really straightforward. There are a lot of data migrations. The only one that needs some care is the migrate instance key pairs. Why? So this is the case where the key pairs are inserted into the instance extra. And this happens and goes well in the top DB cell and database. However, the other cells, the DBs, don't know anything about the key pairs. So this migration will not run. And these databases will later be used in CellsV2. So basically, what we did was create a migration tool to recreate all the key pairs per cell database. In the data migrations for the CellsDBs, nothing needs to be done. And because of that, the DB sync fails because it complains about the flavors. Because with CellsV1, we need to replicate the flavors in each cell database. We just skip that. DB schema, straightforward. However, if you have a huge database, consider to archive, and not only archive, but remove the instances from the archived tables. So deleting the schedule ads could take a lot of time if you have a huge database. And API DB sync also fails, because even if we are running on CellsV1, it checks if any cell was configured. So in this case, easy, you configure a dummy cell, and that's it. Not only in the top cell, in the top Nova API, but also in each Nova API that we created for placement. Otherwise, you cannot do the Nova API DB sync. And one thing that happened in Ocata was the removal of useLocal. useLocal will avoid to connect directly to the database. However, when we did our network driver for Nova Network, of course, we were doing that. And we are in a point that we are migrating to Newton. So the challenge was, we changed the driver, and we may introduce a lot of bugs, and we really rely on this, and it's working fine. Or we change Nova Network to continue to support useLocal, and later it was much easier. So we are running Ocata at this point with 70 placements. So the goal is to go to CellsV2. So the next step is to consolidate placement. Instead of running these 70 placements, we only want to run a placement API in the top cell controller and remove all these Nova API DBs and the placement API from the child cell controllers. So what we expect with this, when we start Consolidate Placement, and this was expected, because placement will send more allocation candidates to the scheduler in the cell, we expected the scheduling time going up, because now the scheduler will loop through more allocation candidates. And actually is what we saw. So these were the first cells that were migrated, so pointing placement to the central one. And what we can see is that the scheduling time is going up. So in this graph, in your left, is the accumulation of all the cells. In the others, we see per individual cell. And there is one, the GVA project 30, that was not migrated, so the scheduling continues to be very fast. How we moved the local placements to the central one, basically is changing the configuration in the compute nodes to point to the new region, and that's it. So we continue to do this cell by cell over a lot of days. Meanwhile, we started to have issues scaling placement, so we needed to deploy new placement nodes, adjusting the number of threads, processes that we are running in the placement. But we are finally there, so we moved our last 50 cells to the central placement. And of course, at that time, the scheduling time was even higher, but it was expected again, and the request time of the placement it also increases. And it's, as you can see, 4 p.m., so everything went fine. We went home, good, we are done. Of course, during the night, everything falls apart, as usual. What you can see in your graph in the right is basically the request time of placement. And we are in a situation where VMs are failing to schedule with timeouts because placement was not answering or was not responding. And actually, this was a very silly issue. We have a memcache cluster for the auth token, and the max number of connections of that memcache cluster was only 8,000 nodes. So it was something that we forgot, and it caused all of this issue. But this is one of the things that in our test infrastructure we never detected. But when we move to production and there are a lot of nodes at scale, these things happen. So changing that value fixed the issue. We also increased the number of placement API servers. So as a summary, so we moved 70 local placements to a central one, and it's not required to copy the data from the local databases to the top Nova API DB. Why? Because all of this is recreated in Ocata. We are running on Apache, WSGI. We have 10 placement APIs. So these are VMs, 4 CPUs, 8 gigs of RAM, configured to run 4 placement APIs, 20 threads. And of course, because now all of this is connecting to the Nova API DB, we need to look after this DB very careful. This means that per each Nova, per each placement API, we have around 1,000 compute nodes. So we did all of this. Now we have the central placement. The scheduling time goes up. However, we had few cells that were performing very well, the scheduling. So what we see in the graph is the scheduling time. So we had 4 cells where the scheduling time was very, well, like in the past, like having in the local placement. So what was wrong with that? In our large infrastructure, we have always nodes broken, nodes that are in repair, nodes that break during the upgrade. And Nova was checking the service version. So if it's not in Ocata, if it was not upgraded, the scheduler doesn't use placement. So that's why we add that low scheduling time. And actually, this was a debug message. Of course, we never run in debug, otherwise we kill our monitoring. So for some time, we needed to dig into the code and try to find out what's going on. One cool thing will be not only checking the service version, but checking if we are getting heartbeats from the compute node when doing these kind of checks. Right, so we consolidate placement. The goal now is to have CellsV2. So advantages, finally, we are using the latest and greatest codes. Nova team love it. We know that because they have these kind of functions in the middle of the codes. And we can remove all our internal CellsV1 patches. Of course, we have some concerns. And the major one is someone else running CellsV2 in the room? There is anyone running CellsV2 with multiple cells? Right, so that was one of the main issues. There is no experience running this code. There are a lot of scheduling limitations and availability and resilience concerns as well. So let's go through the scheduling limitations and the availability. So the way that we're scheduling on CellsV1, one of the use cases that we have is to dedicate an entire cell to a project or more projects. And with CellsV1, we did this with the scheduler filters, with the scheduler filters in the cell. There is no equivalent for this on CellsV2. Scheduler is global, doesn't know anything about cells. Placement also doesn't know anything about cells. And actually, the scheduler needs to receive all available allocation candidates for placement if you are using availability zones. In Queens was introduced this option to limit the number of nodes that are allocation candidates that are returned from placement. However, if you are using availability zones, and because this is a scheduler filter, we may end up not receiving the allocation candidates belonging to the availability zone that we are asking for. So you cannot really limit that. It's not possible also to disable scheduler filters per cell. This was something that we were using. So because the scheduler was local, we had special configuration for that cell, for that particular use case. Now, if we want to have that, we need to enable the scheduler filters, and that will be global. So the looping into the scheduler for everyone will be bigger. And we can disable a cell. So we talked about these issues with Nova team, and they came up with a great idea with the placement request filter. That is the spec. So the initial work is already done in Rocky. Because we need it, we backport all of this to Queens and created our own filters on top of this. These allow us basically to do some pre-filtering in the placement. So now we have availability zone support, project cell mapping, flavor cell mapping. So the filters that we created on top of this. If you have the same issue, please consider the backport few commits from that topic. So placement request filter, it's great for our use case. However, it uses aggregates. So the way that this needs to be configured is create an aggregate. This is in our case. Create an aggregate per cell, add all the hosts to the aggregate, all the metadata, and then all of this information is to be mirrored into the placement aggregates. In that review, this will be done automatically. We also backport that. However, when we configure this for CellsV2, we did this in bulk in the database directly. One of the issues that we have is that this process is very difficult to manage in a large infrastructure because this is very difficult to automate with a configuration management tool because this meant that the configuration management tool needs to have admin credentials to do all these API operations. And that is quite tricky. Forgotten nodes, that are not added to the aggregates will not receive instances. This is very easily to detect in a small infrastructure. If you have 10 nodes, if you have thousands, it's very difficult to detect. Mistakes can also lead to wrong scheduling. This is even worse. And the minor thing is then, when we needed to decommission the hardware, removing an entire cell, this information is not automatically removed everywhere. So that will be cool to work on. So that was the issues around placement, the concerns that we knew before upgrading to CellsV2. Other was availability. So on CellsV1, if a cell goes down, so if the DB of that cell goes down, only the users that are using that cell will be affected. The others will not notice. And that was a big plus for us. One of the main motivations to continue to go through CellsV1. However, with CellsV2, if a cell DB goes down, every cloud is affected. So we will not be able to list instances, create instances. Basically, every user will notice that something is going on. So there is some discussion. Nova team is aware of this issue. There is some discussion of to improve this situation. Please participate in the review of that spec. But looking back, we are running our cloud for 5 years. We never had a big DB issue. So at that point, we felt very confident. Well, let's upgrade to CellsV2. We never had a big issue with the DB, so this will be OK. And then we iterate on this. Of course, you can imagine that we were completely wrong. So everything is done. We are set. We now are going to upgrade to Queens. So the first step is shut down the cloud. And this is really scary. When we have a large production environment and you shut down everything, it's, you don't know if you will be able to bring it up. So, and then the steps are quite straightforward. Basically, upgrade everything, do data migrations. I will not go on detail on this. We need to create all the cells. All these steps take a lot of time. So basically, we schedule that this upgrade will take 1 day. So we open a ticket, we inform all the users. The APIs will not be available for 1 day. And then we executed all of this and tested. That was the plan, the initial plan. And then when we finish all of this, we start the cloud. We don't start the cloud to everyone. We only open the cloud to a very small subset of users, basically us, the admins of the cloud, to start to test things, and to a few probes. And the result was this. So the gaps that you see there is during the upgrade or when we stop the service that is concerned there. So in the first graph is the CPU load of the Nova API servers. And the second one is the CPU load of the placement API servers. And you can see that explode. So around 22% was in Ocata. We upgrade only with few users, and we had that CPU load in our servers. Of course, Novolist was not working or extremely shaky. Creating instances was not working at all. So let's start looking into this. Placement. So this graph shows the number of requests into placement. So until 8, this is Ocata. Everything was down during the upgrade, and then we enable placement. And you see that the number of requests into the placement API jumps completely. And that is the time that we are upgrading the Nova compute. Nova, if you have a large infrastructure, upgrading all these RPMs takes a while, a few hours. So we see that the number of requests is going up. So the initial reaction was, OK, let's add more placement API nodes. So we had 10, we start adding more placement API nodes. And since we add more placement API nodes, the number of requests seems to increase, actually, because actually they were able to consume more. So actually, we are doing something good. And this goes on and go on, and we reach the point that, okay, this will never work. We need to start looking into the code. What changed into placement in Queens? And of course, we tested all of this in our test infrastructure, and it worked fine. We didn't detect anything during our testing. So what changed into placement? There is this new thing about refresh aggregates, traits, and aggregate associated sharing providers that happens every 5 minutes. And turns out this is really, really expensive for placement. You remember the requests and the time that actually placement takes to answer this, to process this. So basically what we did was make this option configurable, and we increased a lot this time. So I think now the configuration is half a year. So do not run this again. However, this worked for Nova Compute, normal Nova Computes. But it is not enough for the Nova Compute in Ironic. Why? Because Nova Compute in Ironic takes care of thousands of nodes. And then the resource tracker goes host by host that is managed by Nova Compute. And this takes around 10 seconds for placement to process this somehow. So it was taking hours only for Nova Compute to do the first round. So basically, we removed, for the Nova Compute in Ironic, we removed all this code path. So we did the changes in the codes, and we deployed a new RPM. And this is the resultant number of the requests of placement. You can see that now this thing goes down dramatically, the number of requests in placement, and actually is less than before. And why? Because during the panic mode, when the number of requests were increasing, we basically stopped Nova computing the entire data center, basically to try to alleviate placement servers. So the 1/3 of number of requests that you see there that is missing is basically because 1/3 of Nova computes were not running, was stopped. After that, everything is perfect in the placement. So we increased a lot. Basically, we doubled the number of placement APIs. So that's why the request time now is pretty low. We have now one Nova placement API per 500 compute nodes. And the average request time is less than 100 milliseconds. So placement is good now. Let's look into Nova API. So we did this exactly the same for Nova API. We saw the CPU load, so the first reaction was to add more Nova API nodes. Doing this, of course, the load goes a little bit down, but at that time we didn't know the reason yet. So we decided, let's open this to the users and see what happens. And I think you can guess when we open to the users. That is the request time of each Nova API call. So what is going on here? With the upgrade, we see that the database load pattern changed completely. And this is right after the upgrade. So at this point, we didn't open to the users yet. You can see that the number of selects in a normal database actually doubles. Basically, without loads. This was only a few users were able at this point to access the API. And the pattern for the connection rate also changes completely. So why? Because with CellsV1, we always care about the Nova top DB, because everything was connecting there. And the others, they added very, very little usage. Basically, it was scheduling and a few updates of the instance state. Now, all DBs are used more or less the same. So we need to now to have a very robust configuration in all of them. And that was not the case. So after reviewing DB configuration, everywhere, moving databases to new servers, basically made it. So, and this reveals the issue with Nova list and Nova boot. So to list instances, queens, it will fail if a DB is down or very slow. Actually, one of the issues that we have was architecture design, because we have two data centers. So we thought, well, it's better to have DBs very close to the compute nodes. So all DB Vigner for the Vigner data center are running in that data center. However, now for each Nova API call, this adds the latency to go to that data center and come back to an answer. Of course, we try to minimize this, basically, and the way that we look into this is instead going to all the cells. So we do a Nova list, and it queries all the cells and tries to figure out which instances belongs to your project. Now we do this, it only goes to the cells where you have instances. And basically, this improved a lot the request time for the APIs. And exactly the same for the quota calculation when creating an instance. And these were the two big issues that we found till now with the CellsV2. After fixing this, basically now the cloud is behaving, it's in a very good state. Minor issues that you want to consider, no availability zones with the API metadata because the app call was removed. This is an important one. If you are using failover with Ironic, and if that failover happens, a new compute node is created for the Nova compute that takes that host. And this triggers the creation of a new resource provider. And this will break the system that we have for the placement request filter. So basically now we are running Ironic with only one Nova compute because of this. The scheduler host manager gathers information about everything, is not parallel. Meanwhile, this has been fixed. Service list, also not parallel, fails if a cell is down. And a very minor thing, Nova Network doesn't run on CellsV2, easily fixed. So these are the metrics that we have today. After fixing these issues, API, request time is pretty good. Placement as well. The thing that we don't understand is scheduling. When you see that red dots, that was what we had previously and what we have after the upgrade to Queen CellsV2. It's still into investigation. We don't understand why. So the final architecture that we have now, basically the top cell controller now runs the Nova scheduler, Nova conductor. We move away the no VNC because it doesn't make any sense to have so many no VNCs. You can see that we increased a lot the number of servers that we are running because of that issue. So we started adding more and more Nova APIs, more and more placement APIs. We are in a point now after these patches that we can start reducing them and see the behavior. So I want to finish this. CERN Cloud is running Nova Queens with CellsV2 with multiple cells. Moving from CellsV1 to CellsV2 is not a trivial upgrade at all. This also depends on your clouds, all the patches that you have, how you are running CellsV1. But the main lesson is that CellsV2 actually works at scale. It's working for us. And of course, there are some still availability resilient issues that we need to figure out. And I would like to finish with a big thanks to all the Nova team, especially Matt and Melanie for all the help during the last weeks. So thank you so much. I think we have 1 or 2 minutes for questions. Yeah.
I put up a graph of database connections going really poorly just a few slides ago. It wasn't clear whether that was the Nova API database or one of the cell databases.
That was one of the cell databases that previously had very few loads, and after the upgrade, had that pattern because Nova API, well, it started using them.
Placement results, that means the results may be not match
I'm sorry, you need to repeat the question or synthesize it. We can talk later, okay?
I think it was back to the max placement results config option, not returning enough of the allocation candidates that you filtered with, like your AZ filter issue.
Yeah, that depends. If you are using availability zones, you may not want that option because the filtering is done after the placement results. It's up to your deployment.
You know I have a patch up for doing AZs in pre-filter?
Yes, I know.
So that should...
Yeah, actually, we have also a patch on this, right? In that case, what I was saying was in vanilla queens. So we may consider all these patches, backport all of this.
And I think in general, the plan is to do as much filtering and placement as possible.
Yeah, that will be great. OK, so thank you so much.